Welcome back. Let's do the problem solving in the section of electrodynamics as we have been taught. Now let's check our skills in answering questions related to this section. Here is a question drawn from the past paper. It's question number 9. So they say to us the diagram below shows the voltage output of a generator. On analysis of this graph, we can see that the maximum voltage Vmax is 312, and the graph is for a DC generator, AC generator, because it's a transverse wave. Continuous rings will be producing this voltage. Then the period of this one is 0.2, you can see. Then let's answer the questions. 9.1, they're telling us to say, does this generator have split rings or slip rings? Remember, split rings is for DC and slip rings is for AC. Therefore, definitely, as we've already analyzed, this will be the slip rings, which will be producing this curve. Slip rings. 9.2. Now they are telling us to say which one of the diagrams below A or B shows the position of the generator. Square at the time 0.10 seconds. You can see in the graph 0.10, it's here. That's where now the voltage is 0. When the voltage is 0, meaning that now the coil should be in a vertical position between the magnets. Therefore, according to the given diagram, then it should be B. Yes, because when it's at B, the EMF will be minimum, which is 0. And at A, horizontal between the magnets, then the EMF will be maximum there. Now the next one is say calculate number 3. Calculate the root mean square voltage for this generator. We go to the formula sheet. We see that in the formula sheet there's a formula of root mean square if we know the maximum voltage. Therefore, we copy that formula as is from the formula sheet. It says Vrms equals to Vmax over root 2. Therefore, we substitute. It will be 312 divided by root 2, which will give us, if you use your calculator, it gives us 220.62 voltage. That is 9.3. Move on. Next question. They are saying to us a device with a resistance of 40 ohm is connected to this generator. Now use this information to calculate the average power delivered by the generator. That is 9.4.1. Then we check average power. We are given resistance. If you look at the formula sheet again, you will find the average power and the voltage and resistance. Then we'll use this formula, which says P average equals to Vrms squared divided by R. Now we are calculating the average power. The Vrms is given is 220.62 as calculated. Then the resistance is 40. In this case, therefore, if you use your calculator, you must get somewhere around 1216.83 watts. That is the power average. The last question here in this question paper, they say to us, calculate the maximum current delivered by the generator. In this case, because we have already found various values, we can use many formulas which has got your Vmax or Vrms. So let's go for the easiest. The average power average will be Vrms multiplied by IRMS. Two ways of doing it. Let's do it in a simpler way and the advanced way. The simpler way will just now substitute to say 1216.83 equals to 220.62, then multiply by, instead of this one I will write now I max over root 2. Therefore in this case I max will give you the value of the current. In this case, when I use the calculator, using the calculator, use your calculator while I'm trying to use mine here. Calculator. So it's 1216.83 multiply by root 2 calculator of mine. It's giving me some challenges. The square root of 2. So this is challenged. Let me see.